ordenador. So, hello guys, who's there? We are two people, please say hi. We are here. So, for people who is there. Okay, so say hi, who is there? Say hi, Nuria, Gemma. Say hi. One moment, guys. Julia, hello. Who else is here? Marcos, we are 9 people, so we will wait like 2 more minutes. Okay. Hi, Andrea, Laura, Lucas, etc. Well, while the people comes, I suppose that many people has delivered the task about energy. The mass of the pendulum is 150 grams. Okay, anyway, it can be done with a mass of 150 kilograms. But now, have a look. I am losing my view. So, many important things. Okay, guys. First, the exams. They are quite well. They are quite well, but there are some menos. There are quite things that worry me about the exam of forces. Okay, anyway, the marks are quite good. Let me check one moment in here. Let me look for the solutions. Okay. There is one thing that worries me a lot. That is, on the inclined planes problems, the procedure is fundamental. This is. You are asked to do all the forces decompositions. Okay. It is not valid to just write that the acceleration is g by sinus of the angle minus mu cosine. Okay, that is the first thing. So please do the pictures big and do well. Paint all the angles that are generated by symmetry, all the decompositions, etc. Okay, that is point number 1. Point number 2, in the exercise about the spring, you have to apply Hooke's law, but the way you had to apply Hooke's law was applying it twice into 2 different situations of the spring. Okay, this means that you got a 2 equation system with 2 things that you didn't know, right? And by solving it, you got that the initial length of the spring is 15 centimeters, although it is not asked, and then the value for the elastic constant, right? Then in the and finally in the car exercise, okay, in the car exercise, you have to draw always all the forces. I mean, although in horizontal surfaces the weight and the normal force are balanced, you have to paint them always, and paint them by two arrows of the same length, and then paint the friction force smaller than the engine force or the motive force. Okay, so this is everything that I have to comment you about that exam. Okay, I suppose that everybody has cleared the end of year schedule, right? This third term. I don't know if we will go back to the high school. Okay, that is the first thing. Second thing, the 21st of May. 21st, I said? One moment. Yes, the 21st of May. We will do the global exam of the third term. Okay, this global exam will work exactly as the midterm. I mean, I will create a quiz in Edmodo with possible answers and an assignment, and you will have to do the test and the assignment. Okay, and in this global exam of the third period, you will be asked about things of this third term. This is motion, forces, energy, and a bit of heat. Okay, but all of them, things about energy and heat, all of them are things that we have already seen. Okay, then, then, um, then the by the beginnings of the last week of May, I will give you your marks. And the 27 people who has to do the retaking exam will be we will do the retaking exam, but it will be of all the year. I think that there is anyone who has passed the first and the second and is failing the third term. Next week, Marcos, we the department are preparing a document for all the students with all the criteria, etc. Okay, I think that the exam is 80 in the mark of the exam. The exercises are 2 points, and the mark is 8 points. I think, but don't obey me. Okay, the 27th we end it. Julia, if everything works well, the 21st you end with physics and chemistry. Okay. Yes, but only for physics and chemistry. The rest of subjects, because we have seen everything, because I am sure that when doing these exercises about energy conservation that you have been assigned, they ring a bell on you. I mean, by this thing of energy conservation, what is up, what is down, the mechanical energy is distributed between the, well, Alvaro, if you get a 0, I suppose that all the exercises that this task that most of you have already delivered, I suppose that you know how to do it. In fact, the first two exercises were done last year. Now, let's go to the following part of the unit. Any doubt by the moment with the mechanic energy conservation? Any doubt? Any doubt in the mechanic energy conservation? Any doubt in the mechanic energy conservation, guys? No, no. Okay, so I suppose that there are no doubts. Okay, guys, so if you please go to the page number. If you please go to the page number 242. Okay, If you go, guys, to this page 224, okay, there you find the definition of work. Okay, now for you and power, these two concepts we have already seen them. Maybe work is new, but it is quite obvious. Look, what happens with work? Work is a kind of energy, and it is expressed by a capital letter W. Also in Spanish, it is expressed by a W, capital W, although in Spanish its name is trabajo. Okay, and it is the multiplication of force by the displacement that this force provokes. In fact, you know that the energy in the International System of Units is measured in joules, right? And 1 joule actually is the energy is the work that a force of 1 Newton does over a mass of 1 kilogram to translate it 1 meter. Okay, this definition is quite abstract, and that is why also the joule is a very small unit, and we normally use the calorie. Okay, the definition of calorie is simpler. The definition of calorie is 1 calorie is the needed energy to increase the temperature of 1 gram of water 1 degree. This is the energy. We have a sample of 1 gram of water at 20 degrees, the energy to take it to 21 degrees. Okay, remember that the difference of temperature in degrees and in Kelvin, it's exactly the same. Now, things. A power is the relation between energy and time. Okay, this and power is measured in watts, in Spanish, vatios. Okay, and this concept also is not new for you. In fact, you know that the power of things it is not the same. I mean, the power measures if I can go from the ground floor to the first floor of the high school, for example, in 30 seconds or in 1 minute. My change of energy is the same, but the time that I have spent in doing this track is different. So my power has been greater on the first case in 30 seconds than on the second case in 1 minute. Okay, because I have spent less time. Right? Do you remember? Do you guys remember these things about potence? Okay, we use the P with foot. Okay. Hmm? Not everybody at the same time, please. If you don't remember, please let me know. Anyway, I will prepare during the after next week. I will upload you the class notes. Okay. The word potence is new for you. The word potent. Wait, sorry. The word potence is new for any of you. You have never heard about potence. In Spanish is potencia. Well, look, the potence, guys, is the relation between work or energy and time. Okay, so when we, for example, buy a car, normally a car's potence is measured in horsepowers, in caballos de vapor. In fact, when you go to buy a car, you are asked about how many horses do you want that car to have. Okay, 1 horsepower, this The measure, it gives us the time that the car needs to go from rest to 100 kilometers per hour. Now, what kind of energy does the car, what kind of energy, which energy is changing in this process? I mean, a car begins from rest and via a UALM, it reaches a speed of 100 kilometers per hour. Now, which energy is increasing in this car? Which energy is it earning? A car begins from rest and reaches 100 kilometers per hour. Which energy does it get? Which kind of energy does it get? Not everybody at the same time. Guys, you should know this. Which energy is linked to the velocity? Which energy is linked to velocity? Kinetic energy, right? So the car's potence, okay, its potence is its kinetic energy divided by the time that it spends in doing this change. So a car that spends 10 seconds in this change, okay, is more potent than a car that spends 1 minute, right? So a car that spends 10 seconds is in doing this process is more potent than that spends 1 minute, right? And there we find that different in price, the price different, okay? Okay, you understand this? Perfect. So things that you already know. Okay, what happens in here? Look, guys, the thing is, point number one, units of potence, watts. Okay, in Spanish is vatio, and its units, its symbol is W. Okay, now, important things. The kilowatt hour is a unit of energy. Okay, it is not a potence unit. And is the watt the only unit? No, there are more units. One moment. There are more units of potence than watt. One very important, a very important unit of potence is in English HP, in Spanish CV. They are horsepower, caballo de vapor. Okay, if you have to do any change in this and it is used, this. In cars and different vehicles. Okay, in fact, you can ask your parents about the horses that their cars have. Okay, now, Now, if we move, guys, to the pages 252 and 253, well, one thing, any doubt in the concept of potence and how to calculate it? No, no. Okay, Julia Laura. Perfect. Now, let's move, guys, to the other part of this unit that you have to know. Look, I will give you two more tasks for this unit. Okay, one will be about work and potence, and the other will be about heat. Right. But and then we will do another class before the exam for solving doubts and doing, if you have any doubt, any general doubt about exercises. But you already know these things about heat that we are going to say. So if everybody can please move. Everybody please moves to the page 253. Okay. Everybody moves to the page 253. And let's talk about heat. Okay. Now, guys, we have seen and you already know that the energy can be transferred by two ways: heat or waves. Okay, waves, they can be electromagnetic or mechanic. This is light and sound. Okay, and heat. Okay, heat is the energy that is linked to temperature. Okay, in fact, we have talked about heat when talking about chemical reactions. If you guys remember, the chemical reactions are classified by their heat in exothermic and endothermic reactions. Okay, and heat is linked to temperature. Yes? Have I said anything new? Perfect. So we're going to see many things about heat. Okay, we're going to review two things about heat. That is, we are going to review two things about heat, its effects on bodies. Three things. Sorry. Going to see review three things about about heat. Okay. One, the thermometric scales. Two, effects of heat in objects. And three, how it is transferred. That is conduction, convection, and radiation. Okay, we have already seen these three things, but just in case any of you doesn't remember them, okay, I repeat the class notes for this, but let's see. The first one, the thermometric scales. How many thermometric scales do you know? How many thermometric scales do you know? No, Alvaro, that is the device. Thermometer is the device that we use to measure energy. Thermometer is the device that we use to measure energy, to measure temperature. Celsius or degrees, they are equivalent. Celsius and degrees are equivalent. Perfect. Fahrenheit. And the other scale is Celsius or degrees. Well, Celsius and degrees actually are different, but they're equivalent. The international unit for temperature is the international unit for temperature is international unit for temperature is Kelvin. Okay. Now, guys, if you remember, these thermometric scales, they are different and they are used for different things. Kelvin, they are used in all the calculations. Okay, any calculations, we use always Kelvin. 0 Kelvin equal to the absolute zero. That is the theoretical temperature at which all the particles would stop. Okay, and equals, it corresponds to minus 273 degrees. That is why, for when we want to take a temperature in degrees to Kelvin, we add 273. Okay, and in the Kelvin scale, there are not negative temperatures. Okay, the second and most habitual thermometric scale for us is the degrees or Celsius. Okay, actually they are equivalent, but they are not defined by the same process. Anyway, for you at this level, the Celsius, 0 Celsius equals correspond to when the ice melts, and 100 degrees or 100 Celsius correspond to when water boils. Okay, in Kelvin, this is equivalent to 273 Kelvin or 373 Kelvin. Okay, okay. And finally, Fahrenheit, 80 Fahrenheit 80 Fahrenheit correspond to 0 degrees, and 212 Fahrenheit equal to 100 degrees. Okay, that is why, and the change between Fahrenheit and degrees is more complicated. The change between Celsius and Kelvin is very easy. We add 273. The change from Fahrenheit to Celsius is more complicated. It is via an equation. Okay. Okay. So we are not going to see that equation this year, so don't panic because you will see it next year. Anyway, in the class notes, I will tell you how to do it. And all the thermometers are based on one phenomenon. On classic thermometers, if you remember, the ones that work with mercury or dyed alcohol. Next, classic thermometers are these ones, the ones that work with mercury or a dyed alcohol. Dyed means teñido, tintado. Right, so these, the classic thermometers are based on a phenomenon that is the thermal expansion. Okay. The thermal expansion in Spanish is called dilatación térmica, right? So this thermal expansion, do you remember about it? Does anyone remember about the thermal expansion? If you don't remember, please say no. If you guys don't remember, please say no. Well, you should, and in fact, you have seen it many times. Do you remember about the thermal expansion unions? I mean, if you figure on your mind the covered yard in the if you figure the covered yard in the playground, okay, la pista cubierta, inside of it there is a thermal union expansion union, okay. Do you remember or not? What is the thermal expansion? If you guys go to the page 253, here you have the definition of expansion. This is when the temperature of an object increases, it grows, it is expanded. The dilatation unit, las puntas de dilatación, okay, they are basic because if they were not, the covered yard will break. Or in the train lines, this is very habitual also. Thermal expansion unions in Spanish are called puntas de dilatación. Okay, and what happens with temperature? That things. ¿Tienes tu Super Bowl en el lavabo? And the things, okay, when they are heated, they get bigger, they get expanded. And the classic thermometers are based on this phenomenon. Okay, on the phenomenon of the thermal. On the phenomenon of the thermal expansion, right? Yes, the mercury, the thermal expansion, guys, the classic thermometers are based on it. Why? Because the mercury or the alcohol can only grow through the capillary tube. Okay, okay. Now, if things, when they are heated, they are expanded. When they are cooled down, the opposite of expanding is the contraction. But you should remember that when things get, when things, one moment, guys. When things, guys, get hot, the temperature increases until one moment. If you guys remember, and this is this triangle, it should ring a bell on you. That is the changes of state. Okay, during a change of state, what happens? During a change of state, what happens to the temperature during a change of state? What happens to the temperature during a change of state? What happens to it? It increases, it decreases, it remains constant. It can remain or change. During a change of state, the temperature remains constant and it doesn't change. Okay. Okay. That is why in the heat graphics, in the heat graphics, changes of state correspond to horizontal trends. Do you guys remember this? Not everybody at the same time, please. So what actually happens, guys, is when an object is heated, okay, when an object is heated, when an object is heated, when an object is heated, it absorbs energy and gets expanded until a situation in which it cannot expand anymore. Okay, and in this moment, it changes of state. Right? Do you guys remember this? About how so this explains how a solid melts, for example. Okay. No? No, Alvaro. If you burn a paper, it gets burned. Okay. But if you heat it, it can grow. Okay. Hay que pasar por detrás 2 veces. Okay. What do you don't understand? Think in a glass of water. Alvaro, think in a glass of water. Okay. Think in a glass of water. If I heat it, it can be heated until 100 degrees. Okay. When I give energy to it, okay, when the glass of water gets energy, the molecules move more. When the glass of water earns energy, its molecules move more and the water gets expanded. Right. Más que se evapora, hierve. Until the situation in which it cannot expand anymore and begins to boil. Hmm? Hmm? So the boiling point is a specific property of the different substances, right? So just like the melting point. Okay? Okay. Yes? Hmm? And the last thing about today, and this is all the theory of the unit, okay? This is all the theory of the unit, is how heat is transferred. Heat can be transferred, heat can be transferred by 3 different mechanisms that are conduction, convection, and radiation. Okay, you can find them explained in page 254. So keeping by conduction means that I have to touch. There must be contact between the hot plate thing and the cooler thing, and they reach to the thermal equilibrium. Okay, so anytime that you touch something that is at a greater temperature of you or lower, you notice this difference of temperature. Okay, the second way is convection, and the convection explains why the air conditioning machines are situated above near the ceilings and the heaters are situated near of the floor. Okay, and this is because the hot air, as its density is lower than the cold air, it goes to the ceiling and pushes the air that is above. Okay, and finally, the radiation is how the heat travels as waves. And it doesn't need a material place to go through. Okay, so these 3 words should ring a bell on you. Anyway, I will prepare you the class notes for this. For today, I remind you work, potence, and heat. Okay, I will upload them, if not today, during this weekend, so you have them to study. Also study with the book. B, pay attention to the Edmodo place, and any doubt, please don't doubt to email me back or contact me but please, in the mornings, okay? In afternoons, I am very, very, very busy, and I don't have time to solve your doubts, questions, etc. Right? Yes. So, guys, live long and prosper. I hope everybody is fine, that everybody is fine. And we talk next week, right? Bye.